Now, let us see bimetallic strip. So, this bimetallic strip is used in thermostat for controlling the temperature of a system. So, this strip is actually very thin, and we have two types of metals, alpha 1, alpha 2, with alpha 2 greater than alpha 1. Suppose they have equal widths of d by 2, d by 2, that is the total strip has a width d and its length is suppose L naught. L naught is its length. So, this is the side view, and you can see this strip is something like this. So, this strip will be like this. So, this is L naught and some width will be there. So, you can see this width is d like this. So, it is two strips. So, we have two strips. So, let us not write here L naught. So, it is just two strips, this medium, this upper and this lower one. Now, what happens? This strip is straight at 0 degree centigrade. So, this is at 0 degree centigrade. The strip is straight at 0 degree centigrade. Now, what happens when the temperature rises? Then this strip forms an arc. This strip forms an arc. So, this forms an arc of a very small angle, say theta. So, this is alpha 2 greater than alpha 1 and this is alpha 1. So, alpha 2 alpha 1. So, now you see here how this will bend, that is important. So, at the outer you see this alpha 2 is greater than, write down this is greater than alpha 2 greater than alpha 1. So, this alpha 2 is greater than alpha 1. So, when temperature rises, this alpha 2 is going to increase more. So, this will bend in this way. You can see this length becomes more than this because alpha 2 expands more. So, this becomes the outer one. Now, we are interested in knowing that what is its radius of curvature, how it bends and all those things. So, now you see here, if this forms an arc, then this angle suppose is theta. So, this length, suppose this is the radius now. So, this distance becomes r from here. So, let us suppose this distance is r. So, the length L1, so L1, this inner one length L1 is actually L naught times 1 plus alpha 1 theta, and that will be equal to this r theta. This is r theta. This is equation number 1. Now, this length will be equal to r theta. What will be that length? So, L2 will become L naught 1 plus alpha 2 theta, that will become r plus d theta. So, that this d will be added to the r, and so this is equation number 2. So, since L1 and L2, so we will equate these two equations. So, from 1 and 2, let us equate theta. So, we will divide it. So, we have L naught 1 plus alpha 1 theta by L naught 1 plus alpha 2 theta is equal to r theta by r plus d theta. So, we wish to calculate r. So, we have here, if I use the binomial approximation, we will get alpha 1 minus alpha 2 theta. I have assumed alpha 2 theta to be more. So, it is r by r plus d, or we will put r by d here, r by d here by r, r by d by r. So, it will be 1 plus alpha 2 minus alpha 1 theta. So, now this is 1 plus d by r is equal to 1 plus alpha 2 minus alpha 1 theta. So, here 1 cancel, implies r is equal to d by alpha 2 minus alpha 1 into theta. So, thus you see that this bimetallic strip is when designed to be straight at 0 degree centigrade, when temperature rises it curves in like that. So, it curves towards alpha 1, that is the strip with lesser coefficient of linear expansion. So, if there is a make and break system, suppose some current is passing and there is a contact here. So, the temperature rises, it bends, so contact will be broken, and so the current will not flow and the temperature will again reassume. So, when again it will reassume, it will become straight and again current will pass, and so this bimetallic strip is used for in thermostat for temperature control.